This meeting is being recorded.
In problem 14, we're told that arsenic is tested for in water supplies because it's known to cause cancers. So this compound given here, the structure that I just boxed in, has been developed to detect arsenic at very low levels. So this means that, this laboratory testing can be done right in the field at the water source instead of bringing samples back to a laboratory. So we're asked here to look at this structure and without using pKa tables, figure out a way to predict which proton is more acidic. So, and then we'll give an explanation of our choice. So first we can start by drawing the two possible conjugate bases. So by that we would deprotonate the nitrogen here and form this first conjugate base up top. And then we could deprotonate the sulfur atom, and then we would end up with this second conjugate base shown down below. So the first conjugate base would have a negative charge on our nitrogen atom, and the second conjugate base would have a negative charge on the sulfur atom. So to compare these, nitrogen and sulfur, they're not in the same row or in the same column, the same group of the periodic table. So we could compare these. So I have a little clip of a periodic table here by using oxygen as like an intermediate between the two. So if we were to take a look here and compare nitrogen and oxygen, since they're in the same row, oxygen is more electronegative than nitrogen. And then we could use sulfur and oxygen to compare by size, and sulfur is a larger in size. So for both these reasons, oxygen would be better than nitrogen to stabilize a negative charge after deprotonation due to its electronegativity. And then sulfur would be better to stabilize a negative charge than oxygen due to its larger size. So then we could deduce through these two comparisons that sulfur must be more capable of stabilizing a negative charge than nitrogen. So therefore, the more stable, weaker conjugate base would indicate a stronger acid, and then therefore the proton on our sulfur atom is expected to be more acidic. So this proton over here would be more acidic.